President Trump says the rapid rise of the Chinese artificial intelligence company DeepSeek is a wake-up call for the US tech industry.
The release of DeepSeek AI from a Chinese company should be a wake-up call for our industries that we need to be laser-focused on competing to win.
DeepSeek R1 started as just another AI experiment, a so-called side project that few outside China paid attention to. But what happened next sent shockwaves through the entire tech industry. This cutting-edge AI model, developed in near secrecy, has suddenly emerged as a game-changer, challenging the dominance of OpenAI, Google, and other Western tech giants. Experts are now scrambling to understand its capabilities, and some are even calling it a major threat. So what makes DeepSeek R1 so powerful, and why is the industry so shaken? Let's dive into the full story, DeepSeek V3. To truly grasp the significance of DeepSeek R1 and why it's causing such a stir, we need to look back at a research paper released in December 2024 titled DeepSeek V3. This model was enormous, with a staggering 671 billion parameters. But here's the twist. It used a special design called a mixture of experts. This means it didn't rely on all 671 billion parameters every time it was given a task. Instead, it only activated about 37 billion parameters for each request, making it more efficient. What really makes this model stand out is one particular detail, which is DeepSeek V3 only needed 2.78 million H800 GPU hours for its full training. To put that in perspective, GPT-4's training took about 60 million GPU hours, more than 20 times the amount. And while GPT-4 used high-end A100 GPUs from NVIDIA, DeepSeek V3 relied on H800 GPUs, which are less powerful. The reason for this difference is that the US has restrictions on the types of GPUs it can send to China, where DeepSeek V3 was trained. So NVIDIA developed these H800 GPUs to meet those restrictions, but they aren't as fast as the A100s used by American companies. Despite this, DeepSeek V3 was able to train 95% faster than GPT-4, even though it used less powerful hardware. Now let's talk about how well DeepSeek V3 actually performed. When compared to GPT-4, represented by a darker yellow line, and Claude 3.5 Sonnet, the final line, it performed impressively. In math and coding tasks, it outperformed GPT-4 and came close to Claude's performance. In a benchmark called MMLU, which tests a variety of tasks for large language models, DeepSeek V3 ranked second, just behind Claude 3.5 Sonnet. For math, it scored higher than almost every other model. In coding benchmarks like Codeforce, it left its competitors far behind. On Swebench, which tests AI's ability to solve problems from GitHub, it was barely beaten by Claude 3.5 Sonnet. DeepSeek V3 managed to achieve results that were on par with GPT-4 and Claude 3.5 Sonnet, despite requiring 95% fewer GPU hours for training and using less powerful hardware. And the best part is that it's open source and available to the public. However, just as this research was gaining attention, newer models like 01 and 03 were being released, shifting the spotlight onto these next-generation models. As a result, the benchmarks for DeepSeek V3 didn't seem as groundbreaking compared to these newer models, even though it was still an impressive achievement. So why is everyone getting so upset about it now? Let's find out. DeepSeek R1. Recently, DeepSeek unveiled some exciting new research with their DeepSeek R1 model. The R1 is built on the DeepSeek V3 framework, the very same model we saw earlier, which was impressively fast and much cheaper to train, even on lower-end GPUs. But here's the twist. DeepSeek R1 takes that already great V3 model and refines it further using a new, cutting-edge fine-tuning process. Now let's dive into the key findings from their research. The abstract explains that DeepSeek R1 was trained through large-scale reinforcement learning, but without relying on supervised fine-tuning as a first step. In simpler terms, they tested the model by asking it a series of questions whose answers they already knew, then had it check its own responses against a pre-existing answer key. It's like giving the model a pop quiz and letting it correct itself along the way. This unsupervised learning method allowed R1 to solve problems on its own, whether it was math, coding, or any other task they wanted it to master. What makes R1 especially interesting is the way it processes and thinks through problems. When you ask it a question, it doesn't just blurt out an answer. Instead, it engages in a chain of thought reasoning process. It will think through the problem step by step, sometimes even rethinking its approach and adjusting its answer if it finds a better way to solve the problem. While the research paper doesn't go into great detail about this, we can see from the way the model works that it requires the reasoning process before giving the final answer. This reasoning process sets R1 apart from other models, including DeepSeek V3. While V3 was already known for being cheap to train, the new R1 model takes it up a notch by using reinforcement learning to fine-tune its abilities and incorporating this chain of thought technique during the process of answering questions. This makes the model not only more accurate, but also more intelligent in how it approaches problems. When you compare it to OpenAI's state-of-the-art closed models, DeepSeek R1 now performs just as well, if not better, and it's open source. That's why there's so much buzz surrounding this release. People are realizing that we now have access to a model that can produce results just as sophisticated as the best proprietary models, but at a fraction of the cost and with more room for improvement. It's a game changer. In this benchmark comparison, we're looking at 3 different AI models. The blue bar with small lines represents DeepSeek R1, the dark gray bar stands for OpenAI 01, and the light blue bar on the far right shows DeepSeek V3, the earlier version of R1. Now, if we analyze the results, we can see that DeepSeek R1 either outperformed or matched OpenAI's 01 model in nearly every test. When it comes to coding, R1 performs just as well as 01. In math-related tasks, R1 beats OpenAI's 01. For general use, both models are about equal in performance. When solving complex problems on GitHub, R1 is actually leading the way. Now here's where things get really interesting. OpenAI 01 is a closed-source model that costs a minimum of $20 per month to use. It was trained on thousands of NVIDIA's top-tier AI chips, like A100S and H100S, requiring massive amounts of computing power and time. But DeepSeek R1 was trained on far fewer GPUs in much less time, yet it delivers the same level of performance. And that's what's making people nervous. This brings us to the shocking news. China's DeepSeek AI breakthrough has sent shockwaves through the stock market. Major US tech companies, including NVIDIA, Meta, Google, and Oracle, saw their stocks take a hit today. The reason is that investors are starting to realize that if companies can train AI models at a fraction of the time and cost, they may not need to buy nearly as many expensive GPUs as before. That could spell trouble for NVIDIA and other big tech firms that rely on selling high-powered chips for AI development. What's really incredible about this whole thing is that DeepSeek isn't even the main focus of the company behind it. It's just a side project. According to a tweet from Han Xiao, the company that owns DeepSeek is actually a quant trading firm. These guys have been working together for years and have some of the sharpest mathematical minds in the field. But here's where it gets really interesting. They originally bought massive amounts of GPUs for cryptocurrency mining and high-frequency trading. At some point, they realized they had way more computing power than they needed. So instead of letting all that extra power go to waste, they decided to train their own AI models, leading to the creation of DeepSeek. Han also pointed out something unexpected. Despite DeepSeek's success, nobody in China really takes them seriously. It's not that Chinese AI teams are naturally more efficient or ahead of the curve. It's just that DeepSeek itself is an outlier. Most Chinese AI companies, just like their American counterparts, are weighed down by marketing and bureaucracy. But DeepSeek is operating with a lean, focused team, making the most out of every resource they have. But will NVIDIA bounce back? Let's explore further. NVIDIA stock controversy. Lately, some investors have been getting nervous about NVIDIA's stock being overvalued. When news broke about DeepSeek's AI model possibly needing fewer GPUs to train, some saw it as an excuse to sell their shares. A few people started selling, which caused a bit of a panic. As panic spread, more and more investors followed suit, making the stock dip even further. But here's the thing. Some people believe NVIDIA will bounce back, and they have some reasons to back that up. Let's start with the controversy surrounding DeepSeek. According to an Investopedia article, analysts at Citibank questioned whether DeepSeek really achieved its results without using NVIDIA's most advanced chips. Despite the concerns, Citibank still recommended buying NVIDIA stock, arguing that major AI companies in the US would likely continue relying on NVIDIA's high-performance GPUs. Adding to the skepticism, Alexander Wang, CEO of Scale AI, also doubted DeepSeek's claims. He wasn't convinced that they used as few GPUs as they claimed, nor that they relied solely on NVIDIA's H800 chips, the less powerful versions of the H100S, which were modified to comply with US export restrictions. Instead, Wang believes DeepSeek actually used around 50,000 of the more powerful NVIDIA Hopper GPUs, H100S, but couldn't admit it publicly due to trade regulations. If this is true, it means DeepSeek's AI model wasn't trained as efficiently as they suggest, and NVIDIA's GPUs are still in high demand. But that's not all. There are rumors that DeepSeek may not have built its AI model entirely from scratch. Some speculate that they might have started with an existing model, like Meta's Llama, and trained on top of it. However, after looking into this claim, there isn't much solid evidence to support it. The only thing that raises eyebrows is that some AI-generated responses from DeepSeek's model reference OpenAI and ChatGPT, making it seem like their model was trained on publicly available ChatGPT-related data. But given how much OpenAI-related content exists on the internet, it's likely that this was just part of their data set rather than proof of them copying another model. To make things even more interesting, a prediction market website called Manifold allows users to bet on whether DeepSeek misled people about the GPUs they used. Right now, there's a 38% chance that they exaggerated their claims. That means while some are suspicious, most still believe DeepSeek is telling the truth, though we don't have solid proof either way. Many investors panicked because they believed this news meant AI models could now be trained with significantly less computing power, making NVIDIA's expensive GPUs less necessary. Many experts argue that DeepSeek likely used far more powerful GPUs than they admitted. If they actually relied on H100S instead of H800S, then NVIDIA's dominance in AI hardware remains intact, and the fear that AI can be trained with less compute is overblown. Even if training AI has become more efficient, companies will still invest in even more computing power to build even more advanced models. If today's AI can be trained with half the compute, imagine what could be built by doubling or even multiplying compute power by 10x or 100x. Instead of hurting NVIDIA, this efficiency might push AI companies to buy even more powerful GPUs to train next-level models. While the stock dip scared some investors, the bigger picture suggests that NVIDIA's technology is still critical for AI progress. If anything, these developments could encourage companies to push AI even further, which means more demand for high-end GPUs, not less. For a while, people mulled over an intriguing idea, though it turns out many others had already thought of it too. If the cost of training AI models drops significantly, it could completely change the landscape of the industry. Big AI companies like OpenAI, which currently dominate the field, might no longer have such an unshakable lead. Lower costs would allow many new startups to enter the market, and open-source AI projects would flourish. Of course, all of these would still need computing power to function. At first, it might seem like AI companies would buy fewer GPUs, since training AI models would require less computing power. But there's a twist. This could be outweighed by an explosion of new companies stepping into the AI game. Instead of a few big players purchasing massive amounts of hardware, we might see a much larger number of smaller companies each buying a modest amount. In the end, the total demand for GPUs could actually increase rather than decrease. After these thoughts were shared, an earlier post from entrepreneur Gary Tan surfaced. He had already pointed out something similar a few days before. He posed an important question. Do people really think that making AI training cheaper and more efficient will reduce the demand for computing power? If anything, the opposite might happen. As training AI models becomes more accessible, the real challenge shifts to their usage, known as inference, which requires enormous amounts of computing power. If AI is easier to build, more people will use it, driving demand for GPUs even higher. This ties into a fascinating economic principle called Jevons paradox, something Microsoft CEO Satya Nadella also mentioned. Jevons paradox suggests that when a technology makes a resource more efficient to use, people don't actually use less of it, they use even more. For example, if AI models suddenly needed half as much computing power to train, companies wouldn't simply cut their GPU purchases in half. Instead, they'd use those savings to train even bigger, more advanced models, or simply build many more of them. So while individual companies might spend less on GPUs per model, the overall demand for computing power is likely to explode as more players join the AI revolution. In the end, this shift could be a massive win for companies like NVIDIA and others selling AI hardware. But did DeepSeek really achieve what they claim? Or is there more to the story? Let's dive deeper. How to use DeepSeek. Right now, anyone can use DeepSeek in a few simple ways. You can visit their website at deepseek.com and try it out directly. Just click on Start Now, and you'll log in using your Google account. If you want to use the R1 model, all you need to do is select the DeepSeek R1 option. This ensures you're working with the R1 model, which has the ability to create and solve complex logic problems. When you do this, you can actually watch as it thinks in real time. It starts by brainstorming, generating ideas, and outlining the problem. For instance, it might think of a classic puzzle with 3 types of people, or try another angle, refining the problem as it goes. This step-by-step thought process is what sets R1 apart from its predecessor, V3. R1 is designed to actively work through problems, showing its thinking at each stage, unlike V3, which lacks this level of interaction. For example, R1 took nearly 4 minutes, 208 seconds, just to come up with a logic problem and solve it. This detailed thinking is a key feature of R1, as it uses reinforcement learning to continuously improve its problem-solving abilities. But DeepSeek isn't just available through the website. It's also the top app on the iPhone's free app store, so you can download it and use it on your mobile device. This surge in popularity has even helped it surpass ChatGPT in terms of usage. However, there were some issues with new signups for a while, as reported by Business Insider. DeepSeek had to temporarily limit signups to only users with phone numbers from China due to large-scale malicious attacks. This problem seems to have settled now, but it's worth keeping in mind that there may still be some occasional glitches. If you're looking for a faster version of DeepSeek, there are also distilled versions available. These use smaller underlying models, but still benefit from the advanced thinking of R1. One such version is available on Grok, a platform that uses a distilled Llama 70B model. This version is extremely fast, so when you prompt it to create and solve a logic problem, it does so in just a few seconds. Grok's speed is thanks to its use of cloud GPUs, which blow away most other platforms in terms of processing time. You can also use DeepSeek locally on your own computer if you prefer. A tool called LM Studio makes it easy to download and run various models. After downloading LM Studio, you can search for DeepSeek models like the R1 distilled Quinn 14B model and run them without needing an internet connection once the model is downloaded. The model was tested on an NVIDIA 5090 GPU, where it solved a logic problem in just under 2 minutes, spending approximately 1 minute and 55 seconds processing the task. The speed and privacy of running it offline are big advantages. With LM Studio, you don't have to worry about your data being sent to the cloud, which is great if you're concerned about privacy. Once the model is downloaded, it can run completely offline, meaning all your data stays local to your machine. If you think that's the end of the story for DeepSeek, think again. On January 27, 2025, the same company behind DeepSeek announced new research about their AI image generation model called Janus Pro 7B. This new model, which is still fresh on the scene, has been benchmarked and outperformed some of the biggest AI image models, like SDXL, Stable Diffusion, and Meta's EMU3. General, this shows that DeepSeek isn't just making waves in language models, but is now also entering the world of AI-generated art. As DeepSeek continues to grow, expect it to make headlines more and more. So far, it's been a game changer in both language and image generation, and it's likely to affect industries in unexpected ways. While some people think it's just a short-term trend, only time will tell how DeepSeek will continue to shape the future of AI. Now you know how DeepSeek works and why it's making such a big impact. Whether you're using it on the website, through the mobile app, via Grok, or running it locally with LM Studio, this tool is revolutionizing how we solve complex problems. And with new advancements like Janus Pro 7B, there's no telling how far DeepSeek will go. What do you think about China's DeepSeek R1? Share your thoughts with us in the comments section. Don't forget to like and subscribe.